Hello and good morning, CSI258 Section 847 students for the second 8-week term of the spring 2015 semester at Anne Arundel Community College. Today's Packet Tracer tutorial is going to be on Packet Tracer Activity 5.2.1.4, and this is the first in a series of Packet Tracer activities where we're going to be taking a look at how to configure Network Address Translation, or NAT. We're going to see all three types of NAT, and we're going to configure all three types of NAT: static NAT, dynamic NAT, as well as NAT overload, which is commonly referred to as PAT, and that's P-A-T. Okay, so let's jump in on this first activity here, and we're going to start out very inductive approach. We're going to start out with the easiest of the three NAT configurations, and that is the static NAT. So our scenario is here. We're going to be using private addresses on our inside network, which are going to be the 10.0.37.205, or I'm sorry, yeah, the 10.0.37.205, the 192.168.95.108, and we have our router here, and then we've got our switch on the inside of our network, and we've got our server here. So before packets with a private address can cross the internet, they need to be translated to public addressing. And remember that the RFC 1918 addresses, right, that those addresses are not publicly routable. But when I say RFC 1918 addresses, we're talking about, let me make this a little smaller here, we're talking about the 10.0.0.0 all the way to 10.255.255.255, and these are our Class A. Then we have our Class Bs, the 172.16.0.0 to 172.31.255.255, and those are our Class Bs. And then we've got our 192.168 excuse me, 168.0.0 to 192.168.255.255, and these are our Class C addresses. And it's also a good idea, if you have an opportunity, to take a look, and let's pull up a new tab here, would be to take a look at RFC 1918, and we'll look at it in PDF format here. Whoops, there we go. RFC 1918, and we'll clear the screen there real quick. We'll move that out of the way. Close that down. So here's the RFC 1918, and this talks about the address allocation for private internets. And if you scroll down, you can see here where in section 3 it actually lists out the private address space, right? And so this is where you could come take a look, and you could actually read through and see some of the rationale and thinking behind why the RFC 1918 was even pursued, right? And it was basically because we wanted to use inside addresses, private addresses that were not routable on the internet, right? Okay, so let me go ahead and iconify that. All right, so back to our static NAT here. So we're going to test access without NAT. So attempt to connect to server 1 using simulation mode. So here's server 1. We'll just go ahead and pull up PC1, and I'm going to go ahead and say ping 10.0.37.205. And as you can see, I can ping myself. Now can I ping the outside address of what we'll go ahead and say is a web server. So I'm going to try to ping 64.100.50.1, which is the address here of server 1, and I'm trying to ping that outside address. As you can see, we're getting destination unreachable. Can I ping the inside address? So 172.16.16.1, and again, we're getting destination unreachable. So let's go ahead and say from PC1, ping the R1 serial 000 interface. And so as you can see here, the R1 serial 00 interface, let's go ahead and pull R1 up because we're going to have to do some configuration here. Leave it right about there, and we'll stretch it a little wider. There we go. So if I say enable to go from privilege exec, or from user exec to privilege exec, and then show IP interface brief. Let's go ahead and take a look. So serial 000 is 209.165.128.30. So from PC1, can we ping that address? Let's try to ping 209.165.128.128. And we can. We do have connectivity with ping from PC1 to the outside interface, right? The internet-facing interface here on router 1. All right. So step 2, we're going to view the R1 routing table and the running config. So view the running configuration on R1. Note that there are no commands referring to NAT. So let's say show run. So we've got our logging commands there for the service timestamps, our host name. Ceph is on. We've got our inside interface, the gig 00. We've got our outside interface, the serial 000. You can see there's no IPNAT inside, no IPNAT outside commands. And it looks like they're exporting version 9 NetFlow, which is flexible NetFlow. And that's it. So there's really not a lot of things configured on router 1. So we're going to verify the routing table does not contain entries referring to the IP addresses used by PC1 and L1. So let's say show IP route. So as you can see, I only have connected route entries and the L for the local entry that corresponds to that connected entry for 172.16.16, which is my LAN, and then the 209.165.128, which is my connected interface out to the internet. And one of the things when we're looking at this picture that may be confusing is this is considered the internet, and we have two addresses here, 192.168.95 and 10.00.37.205. These are both RFC 1918 addresses, right? So, however, the way to look at this is that this is the internet on this side, and that this is my inside local addressing, right? So remember, this is the inside local addressing. These guys out here would be considered the inside and outside. Get outside in here. Whoops. Global. Right? So this is the inside and outside global out here, at least in this setup. And it may be a little confusing again because they're using RFC 1918s out here. And it may be that what they're trying to depict here is that these connections are coming from inside other organizations that just happen to connect into the internet. However, when we're talking about our NAT setup, this is going to be our inside local, and we're going to give it an inside, I'm sorry, that's our inside local, and we're going to give it an inside global address when we do our NAT configuration. So I'll leave this up here just to kind of define a little better what are we talking about in terms of what's the inside of my network and what's the outside of my network. All right. So we have no routes to anything out on the public internet. So what we're going to do now is we verify the routing table, verify that NAT is not being used. So let's say show IP NAT translations. And I'm going to miss a typo there. So show IP NAT, let's do trans. And we have none, right? So there are no IP NAT translations right now. So we're going to configure static NAT. And again, static NATing is of the three types of NAT, definitely the easiest to configure because there's no access list involved, at least not at this level, and we don't have any pool that we need to figure out or configure. So let's go ahead and jump in here. It says refer to the topology, create a static NAT translation to map the server 1 inside address to its outside address. And so again, I'll come up here. So this is the inside local, and this, it says the outside address, but think of it as the inside global. And that's where these terms can be a little confusing because typically any address that's on the outside of the network, you commonly don't hear people refer to it as, oh, that's my inside global address. You'll hear people just say, oh, that's the outside address, right? And then that compounds the confusion because we've got outside global, outside local, right? And actually, we're going to get rid of that. We've got outside global and outside local, right? And that's where it can typically become confusing. So this is our inside local, is the RFC 1918 address. Whoops. RFC 1918 address. And our inside global is going to be the publicly routable, or the global IP address that's reachable globally on the internet. And so we've got all the information we need. Let's go ahead now and knock that configuration out here on router 1. So we're going to go ahead and go into global config mode with configure terminal. And again, static NAT is very forward. So it's IP NAT source source static. IP NAT, or NAT inside, sorry about that. IP NAT inside source static. And now we're simply going to put our inside local address, which is 172.16.16.1, and we're going to map that to the inside global address, which is 64.100.50.1. All right, and so in terms of configuring the router and setting the static NAT statement up, that's it for the statement. But now what we need to do is we need to let the router know on which interface am I going to be doing the outside NAT receiving and the inside NAT receiving. So we're going to go ahead and go into interface gig 00 and just simply say IP NAT inside. And so what we're saying here is this is going to be my inside interface right here. So when traffic is coming this way and it reaches the gig 00 interface on router 1, it's going to look up in the NAT translation table to see, do I have a static NAT for the inside local address? And just the opposite, right? So here on the outside, right, that's going to be my outside, my publicly facing interface. When traffic is coming into that interface, the router is going to look at that traffic and say, okay, the destination IP, is that inside global destination IP that I'm seeing, do I have a translation to an inside local IP that I need to be forwarding that traffic to? And so those are the two statements that we're going to require on the router. So we'll go ahead and say IP NAT inside on gig 00, and then serial 000, I would say IP NAT outside. And so that configures both the inside and the outside configuration on the router for NAT to be activated. So now it says configure the correct inside and outside interfaces. So now we're going to test connectivity. So let's open PC1 back up here. And we're going to ping, and it's asking us to attempt to ping the public address. So we're going to try to ping the inside global address for server 1. And that's going to be our 64.100.50.1. And let's see what happens. So the first request timed out, and then we've got connectivity. So now when I ping, we've got instant connectivity to that address. So verify that both PC1 and laptop 1 can connect. And so we'll ping again here. So let's say ping 64.100.50.1, and we've got connectivity. Now, the more interesting output is when we take a look here on the router. So let me save my config. And we're simply going to say show run. Excuse me. We're going to say show run, and we'll scroll back up here just a little bit. So you can see this is where we put our IP NAT inside command, right? Because we're telling that inside interface that when traffic arrives on this inside interface, do I need to NAT that traffic to an inside global address? And again, the static mapping that we have, we're going to see here in a second. Here's the IP NAT outside command, right? So traffic entering that interface, the router is going to look up the inside global address in its translation table to see, do I have a corresponding inside local address that I need to send the traffic to? And here is our statement. So IP NAT inside source is going to be static. And again, just like with the routing, right? When we did the static routing and the frame relay mapping, I love to come up with like little mnemonics so that when I look at statements, it's almost like you're explaining what it does. So when I look at statements like this, I like to say, excuse me, my inside NAT that I've configured has a static source IP of 172.16.16.1, and on the outside it's 64.150.1, right? So again, I have an inside NAT configured for the source IP that is static, 172.16.16.1, that goes to the outside address, 64.100.50.1. All right, and now let's take a look at show IP NAT translations, because we've had some communication go back and forth. And let me pull these guys back up here. Let's ping again from here, and let's ping again from here. And now let's pull back router 1. All right, much better. So as you can see, it gives us the protocol. That's what the pro stands for, is what's the protocol. So it's ICMP, right? Because we're pinging the server. So it's ICMP packets, excuse me. And it's asking us, what is the inside global address? Well, the inside global address is the 64.100.50.1, and it shows the :25 for the port number, or I'm sorry, for the instance number, not the port number, the instance number. And then it shows us the corresponding inside local address, and then it shows us the outside local address as well as the outside global. And you'll notice that the outside local and the outside global, 99% of the time, these addresses will be the same address, right? There are use cases or scenarios where they are not. And a couple of those are, and these are well outside the scope of the CCNA, but so that you're aware of it, there's something called SNAT, and that's S as in Sam, NAT, right? Or static NAT address translation, when you can set up load balancing. And also when you might see the outside local and outside global being different is if you're merging two companies and you've got overlapping IP address space, where you would have to NAT on both sides. And those are two instances or two use cases where the outside local and the outside global may be different. However, for the curriculum and the material that we're looking at, right, 99% of the time, even almost 100% of the time, it's going to be the same. The outside local and the outside global will be the same. And so you can see here that it gives us a table, but then eventually, right, that table is going to time. You see how we no longer have any of the entries in there because the table, the entries have timed out, right? It still shows us the outside global and the outside local, but it doesn't actually show us the active traffic, because again, we pinged and the traffic showed up and then the traffic disappeared. And this is also an important point, right? The static translations, right? These translations are going to remain in the router. They are not going to time out and disappear. And this is very different from dynamic NAT, where the translations will disappear at some point, because again, they're dynamic. Things are going to be changing, okay? And so again, this is our static NAT configuration. Very straightforward. Consisted of 3 commands, right? The declaration of who are we creating the NAT for? What is our inside static source address? And then what's the outside, I'm sorry, what's the inside global address? I even caught myself saying outside, right? Because very, very common just to say outside, even though it's the inside global. And those are terms that you're definitely going to want to have down, because typically you'll see that that is how it's referenced on the exam. So IP NAT outside on the outside, the internet facing interface, and then we have our IP NAT inside on the inside LAN segment facing interface. All right, so this has been Static NAT Packet Tracer Activity 5.2.1.4, and hopefully this has clarified what Static NAT is, how to set it up, and how to confirm and also verify that you've got your Static NAT translations coming through. And in fact, we've got the one last command they wanted us to do there. I overlooked that. Show IP NAT statistics. And you can see here, so total translations. We have a single static. Where's our outside interface, our inside interface, how many hits and how many misses. And then here are the expired translations, right? And this we're going to see in the next Packet Tracer tutorial that we do when we start to talk about dynamic mappings, right? Because right now we're only talking about static mappings. All right, thanks for watching, and I will see you on Saturday.